Hey, y'all. One more week, a bunch more topics. So, hope you're ready. Let's dive in. So, this week, remember that last week was an abomination? I think hopefully, most of us are past that and at least back to a little bit of normalcy. But remember that I sent out that email 2 days ago, and just a quick recap, it reminds you that I've extended the time for all the week 6 stuff. So go check the dates on that. If you didn't get a chance to submit that this week. I've got that extended out to Sunday, 11:59. So same as this week's stuff. Now, here's the deal. That kind of throws everything off, just kind of totally skipping a whole entire week, as I think most of us did. I don't think we had a choice. But because of that, please reach out and let me know if you're having issues keeping up or anything like that. Like I said, a week throws everything off. So just stay in touch, and I will work with you to make sure that you get everything in. I do not want last week to be the reason that you're having an excess amount of trouble. I mean, everybody has a little bit of issue in Linux. Linux is hard. It is not Windows, so I totally get that, and I'll work with you with that. But I understand that last week, just one of those things where we can't really control it. But the directive is to just keep on trucking. So we do have as a last ace in the hole, as I mentioned in the email, we do have that last week. We have an additional week at the end of the semester to lean on if we have to. But as I said, the directive. So what I'm being told is just keep working as normal, and if we need to use that last week, we can. But we're looking at trying to stay on track. I know that's not going to be the easiest thing in the world, but as I said, just stay in touch with me and we'll make it work. We'll figure out some way to make this work. Anyway, so because we're still moving on, that's this week. Last week's, we didn't have a meeting, so we didn't have a recording, but there is a recording from the previous class that I taught. So it has all the it has all the same information. So just go back and watch that, and it'll tell you what you need to know if you haven't done that yet. Anyway, so this week we're talking about account security. You can think of a lot of the account security as really policies, group policy in Windows, how you can go and change, say, something like, for example, what we're going to be doing today is changing a bit of the password policy. And you can change things like whether or not you can log in, what happens when you log in, what kind of messages do you get, what kind of software you're able to access, things like that. So everything that you can do account security-wise in Windows with group policy, you can do in Linux too. You just use something called PAM. We're also doing some Secure Shell, which is a remote control protocol. So we'll look at both of those things right now. So, PAM. The idea with PAM is, as I mentioned before, it's group policy, really. Let me get logged in real quick. All right. It's basically group policy. You're looking at a few sets of rules on your machine, and those are all controlled by pluggable authentication modules. So, a couple of things we're looking for. Number one is the etc.pam.conf file. This is going to be where global configuration is going to be stored. So let's look at it, see if we have one. Not every system has one, but if you do, it's here. And if you notice, let's look in it. So it starts here, and every single line has a hash mark on it. So this file might as well not exist. The reason it does exist is just so you don't go out and create it and accidentally add something to it or something like that. And also, when you go look at it, you realize that, well, nothing is in here outside of comments. So you can read what's going on in here, and this is important. Most programs use a file under etc.pam.d to set up their PAM service module. So that's just the indication of where we need to go next. And that's here. So there are files in pam.d. And you're going to realize that every single service on Linux, if it has the ability to read from a list of files, it's going to be in whatever .d. So for instance, if you wanted to configure apt, its preferences are in preferences.d. Right, and there may be some in there. There may not be anything in there, but that's not really the point. If you have that .d folder, it really just means you can add files in here with rules, and I'll follow those rules. So in this case, etcpam.d, you can see, and you can do this too. By the way, I know you can't see what I'm doing, but cat /etc/pam.d, and then you hit tab a couple of times, and it'll give you all the options that come after that. And then in this case, it's just a list of files. So we could do ls, and you can see those same things. Oops. All right, but what we are most worried about in this case is common password. So if you look at these, you can see that these are some of the rules that deal with changing your password. These are some of the rules with changing your shell. These are some of the account rules, authentication rules, and password rules. So, I mean, you can kind of go down all of this and come in here and configure a lot of the policies. So I mean, just like in Active Directory, when you're pushing policies to machines, you don't go over all the policies. You really just kind of focus on the ones that you want to play with, and that's exactly what we're going to do in this case. So let's look at the common password module or set of rules. Let's use less, just in case the file is large. I can't remember how big it is. Common password. This allows us to scroll up and scroll down. Okay, so it's not too big. All right, but pretty much everything is hash marked all the way down. But you can see here's where the rules actually start. No hash mark, and you can see what's going on. So what I need to do is get this out of the way for a sec. Here we go. Okay, so you can actually see my mouse. So anyway, you're seeing rules, password, success. Default is to ignore if anything is not success, and these are kind of the rules of it. So use this library to deal with passwords. You want to obscure the password itself, and passwords will be stored in SHA-512 bit encryption. So what we're really looking at, and I kind of have what's going on here. So this is the type of rule. This is how you control it. This is the library or the module that you're dealing with, and these are the arguments that come with it. So here's what's really happening here. PAM Unix.so contains a lot of rules, and those rules in this case, oops, there's a typo there. And these rules, in this case, like I said, obscure when you're typing your password. It doesn't show you what's going on with that password. And SHA-512 is the style that the encryption style that it is storing your password as. So if we look at, let's do. If I can type it. Oh, we're going to have to look in password D for that, or password for that. Maybe not. Maybe I missed it. Oh, maybe if I look at an account with a password on it. So you can see this account right here. So Leo and then $6 right there. That is what is telling you what type of encryption your password has. And then that big long line of gibberish after that is my obscured password. So this is what my password looks like after we have encrypted it. And the idea with that is that, no one can figure out what my password is based on that. And everybody's is going to be different. But anyway, that's the idea. So we have SHA-512 is what type of encryption we're using, and where you see right after that first colon, $6. That 6 means SHA-512. So this is just how we go and check. If you want to know more about what's going on here, manual pages come in really, really handy. So you just want to give it the path to the file that you're dealing with. So pam.d common-password. And you can see, and it's going to go down pretty much everything. It's going to tell you. So like right here, the SHA-512 option enables salted 512 passwords. Without this option, the default is Unix crypt, which is not great. Unix crypt and MD5 are breakable now. So it is just not a good idea to deal with anything not SHA-512 or bigger. Yeah. Anyway, so you can do this with pretty much any of the files inside of PAMD, and it'll give you a quick rundown of what's going down. Yeah. Anyway, so long story short, if you want to add something to it, you just add a space and add what you want. So in this case, what we want is min-len. So this right here is going to add a minimum length. So pamunix.so has an option inside of it called min-len, and it expects, and you set it with an equals, it expects a number here, an actual integer. So you can say 5, or you can say 10, or you can say 100. I mean, your users would hate you at 100. But you can set whatever you want to at that point. And once you save it, any new password that is created will have to follow that rule. So let's do, oh no, it's pam.d common password. And I do like Nano because it does color code everything. So in our case, what we would want to do is all the way to the end of this line, add a space, min-len equals 10. Or you can do 12, or you can do 8, or whatever you want. And once we save this, so Control S to save it, Control X to get out of there. If you create a new password, so if you change your password, if you do passwd, that will change your own password. Or if you were root, you can do, something like that. Change Betty's password. The requirement is now that the password at least meets the length requirement. So there are plenty of other requirements that you can add. Really what I want you to do is to get more comfortable dealing with configuration files. So really that's all we're going to deal with on this. So what I want you to pull away from this is what controls all these policies on Linux. That is PAM, Pluggable Authentication Modules. Where does PAM exist? Here, pam.conf, and here, pam.d. If anything exists in pam.d, they will take precedence over pam.conf. Not every system has pam.conf. But just like with Ubuntu here, I mean, it probably does exist, but it doesn't have anything in it. And this is the basic setup of how a configuration line would be set up. And to add something, a space, and add it. All right. So that's the basics of PAM. That's really all I need you to take away from it. PAM is a super, what's the word here? Super advanced. You really don't deal with a whole lot of PAM in a lot of machines that are just doing simple stuff. So yeah, PAM really is when you're controlling multiple machines across an entire network, you want them to all have the same configuration. You'll use PAM to do this, and some kind of configuration management to propagate those changes. So you make a change in one common password, but you want them to be on all 100 of your servers. You usually do that through some other service. So editing PAM by hand is not really something that we deal with a whole lot. And even then, yeah, you're doing it at a higher level as well. So just know the basics of PAM, and that's what they are. So SSH, this is another thing that we need to deal with, and this is remote controlling a server. So with Secure Shell, that's SSH here, it allows you to do a remote connection to another Linux machine. And this is the coolest part. Doesn't matter if it's CentOS, doesn't matter if it's Ubuntu, doesn't matter if it's anything. If it can run the OpenSSH server, then you can SSH into it from any machine that supports it. So that means all of your Linuxes. Here's one of the cool things. Windows now supports at least being a client for SSH. So you can use Windows to remote control all of your Linux boxes. And that's just built in now. So you can open up the command prompt and type in the SSH command and you'll get, an example of how to use it. As a matter of fact, Mac also has it. So you'll basically, SSH username at server, whatever that is. A lot of times that server part is an IP address, but since I don't have anything to... Oh, actually, you know what? Well, you know what? Let's just show it here because this is how we're going to be using it anyway. So here's the deal. To SSH into something, the easiest way to do that is gather up your username, whatever that is, on the remote machine. So notice here, I'm on CentOS, and up here is Ubuntu. So I want to remote into Ubuntu. So from CentOS, I want to control the Ubuntu server. So the way that I'll do that, I believe that's its IP address. There we go. Usually you'll get a, do you want to save this certificate error? Well, it's not really an error message. It's just a notification, essentially, and you'll type yes. So the first time you connect to something from a machine, it'll ask you, hey, is this the identity of the person that you think you're connecting to? Are you sure? And there are ways to check, but usually, if you set up all the machines, you can usually trust it. The whole reason that you do that is that if that certificate ever changes, so I mean, if someone were to try to impersonate the server that you're connecting into, right? Like they take the IP address of that machine and knock it off the network or something like that. And so now they are 10.20.30.10, like I'm connecting to here, then it will warn you and say, hey, that certificate's different. It's wrong. I don't understand, and I'm not going to connect to it. So it's a security measure. Anyhow, so now you can see I'm on the Ubuntu server. So you can see here, welcome to Ubuntu 18.04. You can cat etc. And this is just extra info. If you want to figure out what you're on, what kind of server you're on, you can cat the OS release file in etc. And that will tell you it's Ubuntu version 18.04.4. It's like Debian. It comes from Debian, and you get a bunch of information. So, and you can do this on CentOS as well. And you can see here, CentOS Linux version 8. It's like RHEL or Fedora, et cetera, et cetera. So, all right, let me clear that off the screen. You don't need to know that part, but it is useful if you totally forget what machine you're on. That's one way to help figure it out. All right, so that's really how you do it. You don't even have to have the username in it. It'll ask you if you don't provide it, but just be aware, this is typically the way that it'll be done. So SSH username, whatever that is, at host, and that can be an IP address as well. So the SSHD configuration file lives here, SSHD config. So on Ubuntu, actually, you know what? Let's have some fun with this. So we'll use CentOS to do all the fun stuff on Ubuntu, just for fun. So let me SSH back in there. All right, so now we're on Ubuntu again. All right, so, oh, you know what? SSHD config is huge. So let's do yet less. Okay, so you can see SSH typically listens on port 22. Since this is commented out, that's really just telling you what the default is, what it's listening on, all of the IP addresses, and as you go down, you can find some interesting stuff. Public key authentication. This becomes important later on. We're going to talk about that later on. But notice right here, down at the bottom, So OpenSSH or SSH servers can be controlled by PAM. So there are modules in PAM to control how your SSH server works. So do note that that is the case. Let's see if I can find it. X11 forwarding is a really cool way to, so you connect with SSH and then you can launch a graphical user interface or just for one window. So if you were logging onto CentOS and you needed to run the firewall graphical utility, you could totally do that in Linux. So you would just type in the name and it would pop up on your screen. So just some interesting stuff that you can do with SSH. Not that you necessarily need to be able to do that right now. Because again, X11 forwarding is another more, what's the word I'm looking for here? More advanced topic that we're not going to cover in this class. Anyway, one of the other things that, here we go, there's the one. Password authentication, yes. So to secure up and to kind of fit it into the security theme, to secure up SSH, you're going to turn that off. So this will forbid anybody from logging into your server via a password. Now, that sounds counterintuitive, right? Because passwords how we get into everything. But please be aware that passwords are probably the lowest form of authentication that you can have. We have way better ways to authenticate now, but I mean, passwords aren't going away anytime soon. But Linux supports this idea of private public key exchange. And so the way that works is there are two types of keys, a public key and a private key. I won't get too far into it because you talk about this in security and you kind of take the whole idea to fruition. And we'll talk about it a little bit more here later on. But suffice it to say that a public key and a private key are like, think of like a master lock that you would put on a locker or on anything that you wanted to secure, just those regular style locks. Here, you know what? Let's look at this. This is because I feel like, here we go. Those, right? So your public key is this. Everybody that walks by can see it. Your private key is this, right? Only you have a copy. And it should always be that way. But here's the thing, right? It takes effort to copy a real actual master lock key. You got to go take it to the store, and then you got to give it to the cutter guy, and then they'll put it in the machine or they'll cut it themselves. And you can get a copy, and it costs money. So it's actually harder to copy a real life key to a master lock than it is to copy a private key. These would be your private keys in this scenario. A private key in Linux or in SSH or however we're dealing with that, right? OpenSSL is really where that comes from. But either way, your private key is this. You keep it as secret as you possibly can. You put it on an encrypted flash drive or something like that to be the most safe, or just on the machine that you created it. It never leaves. So essentially what you're doing is you're logging in with this. So you put the public key on the server that you want to log into, and you have the private key in your machine that you're logging into stuff with, and those will just match. When they match, you are allowed to log in, and you do not need a password to do this. You can add a password to your private key, just in case someone does copy it, right? You still need a password to get into that key, but the key is really the way that you're logging in. So, yeah, just know that is one way that you can log into machines. That is a very good way to log into machines. It's way more secure than just a password by itself. Anyway, so we'll talk about that topic a little later on because that one is an interesting one to configure. Anyway, so the SSHD configuration file is there. Please know that. And there is a file in .ssh called known hosts. All right, so this is what I was talking about a little while ago. I exited the SSH, so now I'm just in CentOS, and I want to look at that file. So let's cat .ssh known hosts. So in that file, you have this, the IP address that you connected to and their certificate. So that bunch of gibberish is very important because it's unique. It is unique to the server that I logged into. And as I mentioned before, if someone tries to, pull a fast one on you and they're now impersonating that server, if their certificate is not exactly that, and, here's the thing, it won't be. The entropy on that is massive. You would not really be able to guess that unless you see it. And, you can see it, but the idea that you can create the certificate that matches that it's impossible. Okay, it's not impossible. It is statistically impossible. So that's the idea there. If that certificate ever changes, it's going to yell at you and be like, "I'm not logging into that. It's not the right certificate. I don't know. Just drop in the connection." And if you do want to log into that machine, then you have to come into this known host file and delete this line, so it does not know about that machine. All right. So SSH is really fancy. It is super cool. You can do a lot of stuff with it. To log in, it's like that. And then you provide your password. And now you're running commands on the remote machine, doing whatever you need to do. Update your machine, install some software, whatever you need to do. You can do that from there. All right. So the next idea is inevitably you run into the situation where you're configuring something or you're doing something and you're like, you know what? This would be so much easier if I could just move the file from here to there. Yep. So in comes SCP, secure copy. That is what that stands for. S for secure, CP for copy. And it works almost identical to the copy command. The idea is the same. So let's see. Let's see if we got any files on here. No, we don't. So how about let's do echo move me. And we'll put that into a file called move me. Okay. So what we want to do is copy a file from here to there. And then I'll show you how to copy a file from there to here. All right. All right. Let me just show you what I'm talking about. So long story short, I want to move the move me file to Ubuntu. I'm on CentOS right now. I created this file. Especially when you have a configuration file, right? You don't want to have to go into every single configuration file and go in and edit 1 or 2 or 12 or 100 lines. You just want to, look, I have it already created. I want to copy this over there, and I want to be done with it. That's the idea with moving files around. So the way that we do that is SCP, and then whatever file you want. So I want to be very explicit with this. I don't want any kind of confusion or anything like that. So I'm going to type in the whole path. And then I want to move it to Leo at 10, 20, 30, 10. So it's pretty much just like an SSH connection. And then where do you want it to go? I'll put it in temp. I have write permission to temp. So let's read this. Let's figure out how this is working. So SCP. I want to securely copy this file, home Leo move me, to this location. So an SSH location or a login, colon, where you want that to go. No spaces in between any of this. So Leo at IP address, colon, path, no spaces. And then you grant password. It gives you progress, right? 100%, 9 bytes. Happened in 0 seconds. It was basically instant. All right. So we can now, let's just go check. Why not? 10, 20, 30, 10. Password is that. ls of temp. And there's our move me file. Created at 11:16, which is about a minute ago. Pretty cool. You know what? I forgot what the name of that file was called. I want to pull a file now. And yeah, I was going to pull this. There was a script in here. I knew I wanted to pull it. You know what? Let's just see what happens if I pull this Discord file. That'll actually give you the progress bar, and you can see how it works. But here's the deal. What I want to do, is use the other command here. Okay, the reason there's two. SCP is old. It has been deprecated. It has been found to have bugs that are fundamental to the way that it was put together. So instead of trying to go back in and essentially rewriting the entire protocol, they threw it away and rewrote the entire protocol from scratch to fix those fundamentals from the ground up. Because what ends up happening in software like that is when you have fundamental flaws in the way that things were put together, they are not easy to fix. They are more time consuming to fix than they are to just rewrite. So in this case, that's exactly what happened. But the cool thing about this is that the only thing you need to remember is that SCP and SFTP do the same things. So SCP stands for Secure Copy, SFTP stands for Secure File Transfer Protocol, and you put them together the same. So the cool thing about this is that if you took SCP, erased that, and replaced it with SFTP, it would work just the same. So let's see if I can make this work. And I want to show you another way to do it as well. Actually, you know what? Let's do it that way first, and then I'll see if I can get the example that I was mentioning before to work. So one thing that you can do is if you want to pull multiple files, you don't want to have to keep writing the same command over and over and over again. You can SFTP into something the same way that you SSH into something. So before it was SSH user at the thing that you wanted to log into, the IP address or the host name. And same way here. So let's SFTP there. And this is the first time SFTP is seeing that, so we want to add that. And there we go. So now we're in this essentially new command prompt, and it's not quite a full command prompt. So while you have SSH'd in, really all we're talking about is moving files back and forth. So it doesn't give you all of the commands and all of the things that would normally be available, but you can still do stuff like this, LSL. So it's not as cool. You don't get the color coding or anything like that, but you can still do some of this stuff. So I want to pull that Discord file. So we get Discord, and let's hit enter. And that's going to put it wherever you did the SFTP from. It's going to do that, and it's going to put it in your, wherever you were, wherever you ran the SFTP command from. It's going to do that. It's going to put that file there. So let's see if that came over. Yeah. But for some reason, it didn't pull anything. So let's see if this works. Oh, wait. Yeah, that's right. Leo at 10 home Leo Discord. Oh, no, this is going to be tough. Got to get this right. Two here. You can, well, you know what? Let's just be explicit. Actually, it may complain because I already have a file named that here. Oh. Did I type it wrong? Oh, I sure did. I knew I was going to typo. There. And it might complain that I've got the file. No. Let's try that again. Oh, wow. Okay. I think I've been this is one of the things that that you'll run into. I think I'm in the wrong machine. I need to name these things better. Yep, I'm in Ubuntu. Yep, that makes a lot of sense. I've totally deleted my file. All right, well, all right, let's exit out of here. Let me try this one more time. That makes a whole lot of sense. So, yeah, the SFTP command didn't work because I was already in the machine that I was trying to remote stuff to. So let me try that one more time. So I'm in CentOS this time. So SFTP, that would explain why I needed to accept that that certificate again. I shouldn't have had to have done that. Let's do the desktop.tar.bz2. Let's use this file. Let me get the whole path in there. Home, Leo. And then I want that to go to, let's just put it in temp. That way there's no ambiguity between, that's what got me. Because they're both home Leo. And yeah. So anyway, so I'm in CentOS. I'm secure file transfer protocoling to Ubuntu. That's its IP address. So in home Leo, there's a file called desktop.tar.bz2, and I want that to copy to my temp directory here. There we go. Okay, that's way better output than I was than we had before. All right, so I'm pulling that file. 100%. It was 183 bytes. It took 20.3 kilobytes per second, and it was basically instant. So let me show you how to do that with just SFTP by itself. I'm probably going to stop this username app. Probably going to stop this in the middle because it's actually pretty huge. But we'll do an ls. I'm going to pull this file, the Raspberry Pi OS, but it's like 4 gigs. So I'm just going to show you what the progression actually looks like. So get, and then we can use tab to finish it off. That way we don't have to type that whole entire thing. And there you go. That's what it's supposed to look like. Oh, actually, that's very quick. So that's what it's actually supposed to look like. And that was very, very fast. So, all right. So that was the file I needed. We can exit out of here, and we can verify. As I said, wherever you ran the command from. So SFTP, whatever that is, right here. Nope. Right here. I'm in the home directory. I SFTP'd into another machine. When I just do get by itself, it's just going to put it wherever you logged in from. And that, in our case, that was the home folder. So there's that file. Okay. rsync is another tool that you can use. It's literally called Remote Sync, and it works in the same exact style. So there's really not a whole lot to talk about there. You can just swap in rsync for SFTP or SCP. So the test will likely have these two. These are the very most common. rsync is tends to be used in for backup purposes, not for single files. Though it can. I mean, you absolutely can. Though single files tend to be done with SFTP. Okay, so let's talk about time. Time is kind of important, right? Everything that you do on the system is logged. Every error message is logged. Every hardware error, pretty much everything. Everything is logged. And if the time is incorrect, you'll have no idea when that happened, whenever anything happened. So one of the things that you do want to do is just check on the date. Is that the right time? And in this case, yeah, that is the right time. Wednesday, February 24th, 11:30-ish, Central Standard Time, 2021. Right, so that is important. But what is also important is being able to modify the date so that it says the date in the way that you want. So the way that you can do that, though, is there are some switches that you can use. So there is essentially a computing standard for how to write time, and that's defined in RFC 2822. If you are nerdy enough, you can go and read the essentially the RFC on this, why we do it, how exactly it's done, et cetera, et cetera. I mean, there's a lot of information on there, and those have to get ratified by the IETF and all kinds of crazy stuff. So you can, if you want to just skip all that and you want to write the date in RFC 2822 in that standard, then you can just give it the R switch, and there. So this is Linux standard. This is RFC 2822 standard. And you can see how that works. If you want to know more, you can do date help. If you pipe it to less, so this output is pretty big. I want to pipe it to something. I want to give all that output to less so that I can use the scroll and go up and down and all of that, right? Because there's a lot, right? And now I can use my arrows and page up, page down to move around. And you can see here, RFC. There's also RFC 3339. That's how you would do that. So date dash dash RFC dash 3339 equals as FMT. You can set a reference file if you want your date to essentially give you the information about a file. If you essentially the last modification time. You can get that with LSL, but this will give you a deeper answer. You can set it to UTC time if you want to just see the UTC time, which is essentially time without in our case, I think it's like -6 right now, time shift. But really what we're looking at is this stuff down here. How to really actually control it to be written the way that you want it to be written. So I've got a few examples here. So let's look at this one. Actually, this one's easier to look at for now. So big Y, little m, little d, big H, big M, big S. So let's go look at what that means. So big Y is year. So I want 2021 in there. Little m is month in the number format. So this will be 02 in our case. D, scroll up a little bit. Day of the month number, so that would be 24, right? Yeah, 24. Big H, big M, big S. So big H is the hour in 24-hour format. You can do 12-hour format if you want with I. M is minute, and S is second. So if you were to type this, you would get the date in that format. So date, %Y, %M, %D, %H, %M, %S. Right, that's not very readable, is it? But the cool thing about this is that this tends to be the way that you will write the date if you want precise file names. So let's say that you create a file every 5 minutes or something like that, a backup of something so that you can roll back in case something bad happens or something like that. You can put this at the end of the file name, and it will you'll be able to tell exactly which file this is, when exactly this file was created, so you know how far back you need to go or something like that. So as far as writing it, if there are spaces in there at all, you'll need these quotes after the plus. And so in this case, %A, %B, %E, %Y, %Z. And then close your quotes. So let me see. Actually, let's just hit enter, and then we can look at it. So yeah, A is the full day of the week. Capital B is the full month. Little e is the day of the month. Y is year. Z is zone, time zone. And then I is 12-hour time for the hour. M for the minute. P for AM, PM. So you can format it however you want to. You can mix and match these things. You can add, 3 different years in there if you want. I don't know why you would do that, but you could. That's really kind of the idea, right? You want to manipulate the date command using these %whatevers to write the date in however you want the date to be written. So that's pretty important. Having date right in the first place. So we're going to talk about how to actually make that work, and we'll use NTP to do that. All right. So if the hardware clock needs to be set and the system clock is already correct, so hardware clock meaning the clock in the BIOS, and your system clock is correct, as in you've set it during install or something like that, but this is the correct time, and you want to set the BIOS time to the same time, you'll run this command. So hardware clock, hardware, so -W. Or you can do, actually, the font's weird. Fix that. So you can do hwclock-w or hwclock-sys2 hardware clock. System to hardware clock, or hardware clock to sys is the reverse of that, or hwclock-s. So if your hardware clock is right and your Linux time is wrong, you'll run this command to sync them. This is the one that tends to be the most useful, because Linux will typically sync with a network time server of some kind. So you always have the right time. You can sync up to the National Institute of Standards and Technology. They have NTP servers. That way everybody has the right time across the entire US. So you can sync up with NIST and then run this command to apply the correct time to your BIOS. So that's just a fairly nifty little command to know about. HW clock may come up on the Linux Plus test, so it's good to know. Anyway, most systems are kept up to date with a network server of some kind. So there's some timekeeper somewhere out there, either on the internet or there locally on your network, and you want to use that server to keep time. You want everybody to have the same time. It's actually pretty important when you have 500 servers that are doing 5,000 different things, and you get error message across the entire network. You want to know exactly when things happened so you can find out if there was a domino effect. Where did it start? How did it start? What was the first domino to fall and why? And without the correct time, you'll never be able to figure that out. So time is extremely important. Okay. So NTP, that's typically the way that you'll do that on most systems, but all the newer Linux systems tend to decide, they have just decided that they want to keep their own time however they want to do it. So by default, CentOS uses Cronny, so they don't use NTP. As a matter of fact, NTP is not even in the repositories anymore for CentOS 8. This is why I'm not having you do NTP on CentOS. I'll have you do it in Ubuntu in the lab. But you use Cronny. So, okay, so please, you do not have to know Cronny. I'm just showing you that that's what's in CentOS. So Cronny D is the daemon. Cronny C is the way you control it. So Cronny configure. And, yeah, you can see what's going on. I just typed in help. And you can see, I mean, there's a lot of ways to deal with a lot of this stuff. But really what I want you to see is to start it, you deal with it like any other service, systemctl. Yeah, cronnyD.service is the name of it, so you'll start it that way. And let me see. I think there's a status. Oh, there's not. How about we do this? There we go. What I'm looking for. I pretty much never use Cronny, so I have to check the man file anytime I want to do anything. Oh, sources. That's what I was looking for. There we go. Okay. So Cronny C sources, this is really just showing you a list of all of the NTP servers that it's using to sync up time with. And you can see our clock is ahead by 977 microseconds. To this one, we're behind 188 microseconds, ahead 299 microseconds, and behind 1498 microseconds, depending on whatever. And then so we'll use that to get a general sense of time and apply the correct one, or apply essentially what's basically ends up being an average. So anyway, as far as everything goes, if we have CentOS across the entire network and all of the machines are using Cronny to query these time servers, then we'll end up with a consistent time across the entire network. So long story short, if you're using Cronny, they tend to be looking at the same exact servers, so then you'll end up with the correct time. But Cronny is not started by default, so we can go back and turn this off. I just wanted to show you that. Um, in Ubuntu, there it is. In Ubuntu, they use timedate.ctl. So this is actually built into Linux now, systemd. This is the same family of commands as system control and journal control and all those other things. So time date control. And you can see that it is synchronized. So that's really kind of the idea. Now, the deal with all of this, though, is that the test, the Linux Plus test, is really just going to be talking about NTP. You won't really talk too much about timedate.ctl, and you certainly won't be talking about cronny. So the idea with this, though, is that we need to look at NTPD. So to do that, nobody installs it by default, so you'll need to go install it. So sudo apt install NTP in Ubuntu, and it will grab everything you need. And then to start it, system control enable NTPD. So system CT, you know what? So enable just enables it on boot. Remember that start will just start it temporarily. Oh, it may just be NTP. Yeah, that's what it was. Okay, so it's not NTPD. Get rid of that. All right. NTPQ. Oh, NTPQ. Oh, I need to. I notice this line returned. So NTPQ-P to find your peers. NTPQ-P. There we go. And it's the same basic thing as cronny. Just telling you all these are the IP addresses. This is the offset. It was 4 seconds off. Here's the delay in getting it. So this is how many milliseconds it took to figure it out, etc. So that's really kind of the idea. And if you want to know more, NTPQ, I cannot type NTP at all. Did I type that right? NTPQ. Let's see what I can do here. No, we'll have to check it out here. Let's see if I can find that. Should have been up there. Oh, but anyway, in the manual file for NTPQ, you can see here. Here's the essentially the definition for each of those things that show up when you do NTPQ peers, like this here. So. Yeah, we may have to come back to the association thing. So I'll just take it out of the notes for now, and then we'll... Because that's odd. Should be there. Yeah, it references it here. So I might just be typing it wrong. All right. Anyway, I'll update the notes with that. Okay. So let's move on to logging real quick. The idea with logging is, right, as I mentioned before, everything is logged. Everything you do, it's in some log somewhere, sometime. One of the most important logs that you'll encounter is syslog, or it's called syslog in Ubuntu. It's called messages in CentOS. So let's take a look. Cat var log syslog. Oh, spell it right. There we go. Yeah, that's a lot. And if you notice, right, look, this is exactly what I had been doing. NTP. It's still soliciting IP addresses or time. And so anyway, so I sent that all to Les, and this right here is basically everything that has happened on the system since we booted. So I booted the machine up at 10 after 10, and then you can see this is all the stuff that's happened since then. Right? Well, that's hard to read. So one of the things that we can do is, if you remember, we used tail before to look at the last few lines. So if something went wrong, this is a good way to go in and look. Bar syslog, it'll give you the last something like 10 lines. Yeah. So you can see the last thing that happened on my machine was NTP junk. And you can tell it to do more. In 20, give us 20 lines. And we can go a little further. Let's make it 30. There we go. Starting right here, you can see still all NTP stuff. Anyway, the idea is that syslog in Ubuntu and messages, so varlog, syslog, varlog messages, those are going to be it's basically the dumping ground for regular log messages. They're not errors. They're not critical issues. They're not, it's not necessarily advice or anything like that. It really is just, I did a thing. Here's proof. Here's what I did. So you can go back and actually check and see what's going on. That's pretty important to have. So this is a good place to look. Now, there's an easier way to deal with this, and it's journal control. Journal CTL. If you type that in, you get a lot of the same messages. But journal control aggregates a lot of different logs. So it doesn't just have syslog, it has dmessage, dbus, which is the thing that handles hardware. So if you see hardware failing, you'll see that in journal control as well. So notice here, it's talking about RAID. This is during boot. And it's got information about my disks. So notice here, ATA3 or ATA6 VBox hard disk, how it's connected, where it's connected, and then it named it SDA. So this is good information, right? So there's a way to manipulate this. Journal control, we can do E, and we can start at the end. That's actually pretty important. And then you can see, look, there are the NTP things that we were talking about before. All the way up, you see NTP, NTP, NTP. But some stuff that we didn't see is like this leap second file. So there's a file in Linux that keeps Linux in the know about when that leap second happened. I forget how it works. It's like, every few years we add a second to the clock or something like that. Anyway, and so you can scroll up and see all the crazy things that's happened. You can see, yeah, right here, I typed in my password wrong. You'll be able to see all of the SSH sessions that I did before. It's around here somewhere. Probably a little further up. Yeah, GNU PG stuff, so there's likely SSH up here somewhere. Well, I'm going to show you a way to look that up here in just a minute. So, yeah, instead of looking through every single log, which is mind-numbing, you can tell it exactly what to look for. So we'll do that here in just a minute. So let's talk a little bit more about how these logs work. Okay, so there is a way, and I ask you to do this in the lab, to add something to the log. And the way that you'll do that is logger. So logger, here I am in the log. Woo! right? Oh, whoops. Ah, ha, ha. Okay, I can't have that many exclamation points. But that actually did work. All right, so what happened here is those exclamation points. When you do 2 at a time, it references the previous command that you did, which is why it has General Control E, because there's 2 double exclamation points. So you have to escape those. Oh, see, yeah, I think you have to escape every single one of them. Sure enough. Let's see if that actually works or not. Yeah, there it goes. Okay, well, you're gonna see 3 different logger messages. So journal CTL, and go to the end, and you'll go to the very end of it, and you can see here. There. So there are the lines that I've added to the log. So this is really cool. You can do things like, seriously, the reason that you would use Logger is, something like begin service testing, and then you can search for that line or that phrase in the log, and then you can start looking at stuff after that point. So. Right, begin service testing, and then you can do something with it. You can run a command, or you can delete stuff, or whatever you want to do, and then that's how you'll know that this is what's important. Right underneath this is the stuff that I did immediately after pushing that phrase to the log. So it's just a way to kind of keep your place in the log and make it easy to search for stuff if you don't know how the log is going to react. So anyway, the way that you'll kind of control this is in rsyslog.conf. In Ubuntu, it's this, rsyslogd50default.conf. So let's go there. We're in Ubuntu, so let's take a look at that one. Let's do less /syslog.d/50. Okay, so let's go in there, and you see all this gibberish. So really the thing that you need to pay attention to are the ones without the hash marks. Those are what are being logged already and how they're being logged and then where. So let's look at this, right? So they look like, phrase.star or star.phrase, or you can even have like authpriv.emerge. So what does all that mean? All right, so I've got some examples. Authpriv is privileged authentication. So basically, anytime your password is involved or anytime escalation, you use the command, the sudo command, or anything like that, those are going to be logged wherever they say they're going to be logged. So in this case, authentication and authenticated privilege is all logged in var log auth.log. So the last part where the asterisk is, it's the type of message it is. So like in this case, emerge is emergency messages. You can find errors and warnings and info as well. But if you have a star, it's all of it. All of it. So this means I don't care where the message is coming from as far as services or anything. If it is an emergency type message, and we're talking like this is panic time, something broke very badly, emergency messages are going to be logged somewhere sometime. We don't have those here. So basically mail.emerge, kern.emerge, auth.emerge, those are going to be logged in their own log files. So, authpriv.emerge would be in varlog authlog. Let's see, mail.error is in varlog mail.error. So you go look at that file to find any errors that happened with mail. And that happens a lot. So any other mail messages go to mail.log. So you can separate them out as far as you want to, or you can just have one big set of logs. So if it's not defined, then if you look here, asterisk.asterisk basically just says everything else go into varlog syslog. Okay. So the last little thing I want to tell you about is that dash. So notice on this line, as you move across, you see that file path to the right, but there's a dash in front of it. That dash basically says you can chill out on this particular log file. It doesn't need to immediately be written. So this means that, if your disk is running at full bore and you've got no time to write logs, this particular log can be put off for a little bit. As for the one above it, there is no dash. That means that you will write the log immediately. That's the idea here, right? Because if someone's trying to log into your machine, it's really important that we know. So there is no delay. But in a case like this right here, there is a delay. You can delay it. They're not typically delayed at all. To be honest, adding that dash is really just for dire circumstances when your whole entire server is being used to the max and, I just can't write the log right now. Okay, fine. You can, in this case right here, you can put that off for a second or two, but make sure you write the log. And again, this one is, don't wait. I don't care how busy the system is. You write that log. Okay. So you can do stuff, tail follow. So tail has a functionality that it will follow. F stands for follow. Var log, what did we say? Syslog? Is that what it was? Yeah. So anything new that happens in the, let me see. Sure enough, cool. Check this out. App update. Oh, cool. So that'll probably give me an auth error. Oh, yeah. Okay. So you can see here started session 19. So you can see that I logged in. But let me. There we go. Okay. So let's follow the auth log. Move to this one over here. Sudo apt update. So this should actually log that I had to type in my password. I need to run updates. And there you go. You can see. Since we're following it, you can see the new stuff. Where did we start? Yeah, right here. You can see session open for Leo. New session 19. Oh, here's where it was. Leo on TTY2. Acted as user root to run the user bin apt update command, and it was opened, the command ran, and then it was closed. So you can see how that works. The auth log. Anytime authentication is involved, stuff gets added to that auth log. And then we can check, I don't need to follow it, but var log. And you can likely see. Nope, nothing about. Oh, you know why? Because apt has its own log. Oh, maybe it doesn't. Let's see if general control has it. Oops. Let's go to the end. Nope. Okay. Then just apt just doesn't log, and then you get the auth stuff here with general control. So that's important to know. You can go manipulate the log file itself, or you can use general control to look at them. Either or. So general control F will also follow. So tail F or general control F, whichever. And then if you do general control F, anything new, yep. So you can see it working. Okay, so I had mentioned that we can pinpoint stuff, and that's actually pretty important. So let's pinpoint NTPD, and then we'll also look at SSH. So Control C. All right, journal CTL syslog identifier equals NTPD. So basically what it's saying is if there's any, so look right here, right above this mouse where I'm jiggling it, look up. If it says NTPD right there, it's going to give me that log. It's going to give me information about anything in the journal that is like that has NTP in it. So you can do that with, I don't remember if it's SSHD or SSH. Let's see, SSHD. Yep, it's SSHD. And then you can see every time I've rebooted, the server came up, the server is listening, the server shut down because we're rebooting. The server came up, the server came up, the server shut down, blah, blah, blah. But now you can see here, this is the multiple times that I logged in from CentOS to Ubuntu right here. And notice that line, PAM is involved. So PAM has rules on OpenSSH, on how OpenSSH should work. Anyway, and then you can see at the end, disconnect. All right, so if you know the name of the service, you can get it like this. And I don't know if cron. Oh, yeah, sure enough. So there's actually nothing, we haven't done anything with cron. Cron is basically the way to automate things. So like you want something to happen at 5 o'clock in the morning, cron will do it for you. That way you don't have to actually run the command yourself. But since there's nothing going on, yeah, you're just going to see a bunch of nothing. All right, so that's one way to do it. You can also do it like this. So that U stands for unit because those services are unit files. So journal ctl-u. And by calling it by the unit actually gives you a little bit more information. So if we do ntpd.service, oops, I think it's ntp service. Yeah, you're going to get a little bit more information about it. So notice you get systemd messages now instead of just ntpd. So this is if you just want things relating directly to ntpd, and this is if you want things relating directly to ntpd as well as things that might affect it in a broader sense. And you can also call the binary wherever it lives. This is very uncommon, but just so you know, it does work that way. All right. So Apache writes its own logs. There are services on the system that might run their own logs, and you can change it if you want Apache to run, to be adding it to journal instead of writing its own log. You can do that here, but if you're trying to access the logs in the traditional way, there is var log. It's like, I don't have Apache installed, but it's basically cat var log Apache stuff. So you can check out the Apache log that way if you don't make any changes. All right, so the last thing we're going to talk about, you've made it, is log rotation. So here's the deal. So you saw how big these files got, right? Every time we got into a log, var log auth log, it's a long file. It's a lot of stuff. It flows off the screen. You have to pipe it to less to be able to, up and down and manipulate it and all that. Log rotation is this idea that we rotate it out every now and again. So basically, we take that file, we change its name, and we create a new file in place of it. That way, periodically, you start with a fresh file, but you never lose the old stuff. It's just called something different now. So let me show you what I mean. So in var log, you can see, notice, you've got syslog. This is the actual log. Syslog.1, this is the most recent of the rotated logs. So syslog1 used to be called syslog, but then it got rotated. So syslog1. And basically what ends up happening is syslog1, so once syslog gets rotated again, there'll be a new syslog1. Syslog1 will become syslog2, 2 becomes 3, 3 becomes 4, 5, 6, 7, 8, 9, 10, 11, 12, on and on and on, depending on how many you keep. And you need to define, well, the system defines how many you keep, but you can go in and change that if you want. And so you can see the same thing here, kern.log. This was the next oldest log, then the next oldest log, and the next oldest log. Notice there's a GZ on the back of that. These get compressed eventually. So this is to save space on the system. You don't have to do this. Text files aren't particularly huge, but in this case, it's 118 kilobytes, even compressed. So that's actually a very large text file, 149 kilobytes uncompressed. There's no GZ here. And this one is 48 kilobytes, but getting bigger every time the kernel does anything. So we got to be aware of that. And then it's dpackage log. I was looking for apt log, but it's not apt, it's dpackage. So if we look in there, we'll see apt updates and stuff. Anyway, but all these logs get rotated. Notice BTMP, BTMP.1, dpackage log and log.1. And so all of these tend to get rotated eventually. But the way that we deal with that is right here, etc/logrotate.conf. So just like PAM, there's a master configuration file, cat etc/logrotate.conf. And let me see, let's do that with less. Oh, that was it. That was the whole file. So this is the basics. If you don't specify information about any particular service that's taking logs, then it's going to follow this. It's basically going to keep 4 weeks worth. After it rotates, it's going to create a new one. They will not be compressed, right? Because compressed is there, but it's hash marked, so that means it's commented out, means it gets ignored. You want information about logs rotating to go into etc/logrotate.d. And so for each service gets its own file, and it says, rotated this time, rotated this time, rotated this time. And if you want to define specific logs to rotate, so var log wtmp, if you look at that particular log, these are the things that it's going to follow along. So it's going to rotate the log monthly. It's okay if no log file exists. Missing is okay. So missing, okay. The permissions of the file are going to be like this. 664, root owns it, UTMP is the group. And then rotate. How many to keep? So we'll keep 1. We only keep 1. After it rotates out, and you have that third file, that file just gets deleted. So same down here, but the permissions are a little different for BTMP. And then here, let's get out of here real quick. And you can see there are other ones. So there are specific rules for UFW, for unattended upgrades, for rsyslog. This one's the most important. And there you can see all of these logs: mail.info, mail.warn, daemon.log, auth.log, user, cron, debug messages, blah, blah, blah. They follow these rules. You want to keep 4. You want to rotate them weekly. It's okay if they're if the log is missing, you won't fail on that. Let me know if there's empty. Do compress it, but don't compress it right away. You can compress it when the system is easy. You're sharing the script between all of these, and then post rotate. So post rotate is basically what happens after you rotate it. So you run this command: user lib rsyslog dash rotate. So this is typically just a script to do something in particular. So I don't know if it's a binary or not. Let's see what it does. Here, let's do this. Figure out what kind of file it is before we just mess with it. Oh, it's a script. So it just runs that script. And we can see what that script does. That's it. Let me see. Okay, so it's killing rsys. Oh, so it restarts the rsyslog service. I see what happens. So, okay. So to rotate the rsyslog service, basically it turns off the rsyslog service and then starts it back up after it's done. That's essentially all it's doing. Okay. But again, you don't need to know that. That was just me thinking out loud mostly. Anyway, so that's it. That stuff should carry you through the quiz. That will also carry you through the lab. The one last thing that I want to show you real quick is that for the lab, I'm having you SSH in from one machine to the other, but that doesn't happen automatically if you're using VirtualBox. So let me show you the last little bit, which shows you how to do this. All right. So you need a network that is common between the two machines that you want to connect up. I went ahead and just put all of my Linux machines on the same network. So first things first, we got to create that network. So let's do this. This is going to be this will be your file menu in Windows. So go to File and then Preferences, and then you'll go to Network. And you want to create a NAT network. So basically, this is going to allow us kind of what we already have. We have internet access, but we can't talk to other VMs, so we have to create a network to do that. I have one in here called LinNet, but to create one, you will not have any. To create one, click on the little plus. It's going to be called NAT network. You can leave it at that. I don't really care. You don't actually have to change any of this. It can be called NAT network. I like to name them because I'll end up with a couple across a few different classes. You can leave that at 0. Leave this last stuff alone. 0/24, you want to keep that. But these two middle numbers you can change. I did 2030. You can do 10.10.10 or whatever you want. 10.10.10, whatever you want, doesn't really matter. Leave that stuff at the back. Leave 10 alone. If you are familiar with RFC 1918, which is private IP addressing, 192.168, 172.16, all the way to 31, 10 dot. If you're familiar with that, you can play around with this. But if you are unfamiliar or unsure in any way, don't mess with that 10. Don't mess with the 0/24. You can choose valid IP, valid numbers here in these two in the middle if you want something custom. Otherwise, just leave it the way that it is. Make sure that it says supports DHCP. All right, so that's it for that. And then in the settings of your VM, you go to network, and then by default it will say NAT. You want to move it down to NAT network, and then choose your network. So if you didn't change it, it'd be called NAT network. Otherwise, it's called whatever you want it to be called, whatever you named it. And that's why I like to name them. That way, there's no ambiguity. I know what I created. I remembered what I named it, etc. So create it, File, Preferences, Network, create the NAT network, and then in the individual VM settings, attach your VM to that network, NAT network, and then whatever you named it. Now, it should just work. It may take about up to 30 seconds, but when you do ifconfig, notice 10, 20, 30, whatever. That's my NAT network. Let me show you. So my NAT network is that 10, 20, 30, and then it's going to assign you your individual machine and IP address on that last octet. And in my case, it's .12. In Ubuntu's case, that's .10. In OpenSUSE, I think it's going to be .13 or .11, one of those. Anyway, but now that you have IP addresses, you can SSH into stuff. You can ping things, so like in my case here, 10, 20, 30, 12, may or may not work. CentOS is really big on having a very strong firewall at the very beginning. So if you install SSH on CentOS, you have to go in and actually configure the firewall to allow connections. And that's why I'm having you SSH into Ubuntu. Ubuntu does not have the firewall enabled by default. Anyway, that's pretty much it. So make sure you do that so that you can make sure that you connect up your VMs so that you can SSH from one to the other. But I think that'll do it. So in the lab, pretty simple lab. I just ask you to do a few things. CentOS, so I mean you're going to log in, but wrong. So you can go and verify that you logged in wrong, and then just write out the command. Don't run it, but write out the command to match the hardware clock to the system clock. Ubuntu, you're going to be doing the same NTP stuff that I did. Verify it's running with system control. You're going to use logger. So basically, you're just adding a line into the log using logger. And I want you to say, write the date and time, whatever that is. It doesn't really matter what time it is. I'm not going to check and verify that your time is exactly right or anything like that. Just I want you to get something in the log manually. And then install. So there's a package in Ubuntu that you need to install if it's not already installed. So sudo apt install OpenSSH-server. That will allow OpenSUSE and CentOS to be able to SSH into Ubuntu. So you can remotely control Ubuntu now. Now, in both CentOS and Ubuntu, what I want you to do is go into their respective log files. Remember that they're in different locations. So check the notes for the location. And then answer these questions. So if I want to find authentication messages, where do I go? But answer for both CentOS and Ubuntu. There's not one answer here. They're actually different. All 4 of these questions have different answers depending on if you're in CentOS or if you're in Ubuntu. So make sure you're answering that, answering both. And then in OpenSUSE, let me see. Oh yeah, we're going to be using SSH. You're going to log in to create a file named copy test. And then finally, you're going to SFTP the copy test from Ubuntu to your OpenSUSE machine. And then you'll take a screenshot right before each of these things. All right. Gather all that stuff up into a PDF for me, please, and then submit. That'll do it. All right. And the quizzes, like all the other quizzes, just some basic questions about the stuff that we talked about this week. If you need help on any of that stuff or clarification on any of that stuff, please let me know, and I'll be happy to help. But other than that, we're done.